Hi, so for today we're going to talk about first order linear differential equation. And we're going to solve some problems involving linear DE. Some of you requested for me to make a video about linear DE. So here it is, guys. So, how do we solve linear differential equation? So, a D is said to be linear if we can actually put the differential equation in this form or in this form. Okay? So, wherein for the first equation we have dy over dx plus p of x. It is a function of x, any function of x multiplied by y, and that is equivalent to another function q of x in terms of x. So if we can rewrite the DE in this form, we say that the DE is linear in y. Okay, as you can notice, y is the dependent variable in this given differential equation. Whereas if that is a linear DE, linear in x, we can rewrite d in this form, wherein we have dx over dy plus some function of y, p of y in terms of y multiplied by x, and that is equivalent to some another function q of y in terms of y. And if we can rewrite the DE in this formula, we say that the DE is a linear in x, as x is the dependent variable here. Okay? So, x and y are not delimited dependent and independent variable in solving differential equations. For example, in the application of DE, we can see equations such as the change in current with respect to time. That is, the current is represented as I, and the time is represented as t. So as you can see here, this is not the form of either of the two equations. So here is only the form of which we can actually rewrite the DE, but that is not only limited in the dependent and independent variable such as y and x. It can vary. For example, in the circuit, we have di over dt, where I here is the dependent variable and independent variable is the t. So for some not applications of linear differential equation, of course, we simply use x and y's. Okay? So if the d is linear in y, we have the formula to take note. Okay? Wherein this side of the equation is y multiplied by e raised to the integral of p of x, whatever p of x is here, okay, dx, and that is equivalent to the integral of q of x, here's the q of x, multiplied by e raised to the integral of p of x dx, and evaluated in dx. Okay, the integral is evaluated in dx. So, what is this e raised to integral p of x dx? That is the integrating factor. Okay? But in our discussion for today, we're going to simply use this formula, this following formula. We have a mnemonics here during my review time, so I don't know if that would be helpful for you. We actually memorize this formula as yes pdex squest pdex. Okay, so but we can memorize this. Okay, so if that is a linear in x, if the differential equation is linear in x, meaning we can express the d in terms of this form, then as we can notice, this y is simply replaced by x. So, and this p of x is simply replaced by y, and of course, our dx is replaced by dy. So, same formula. Okay, so we have x times e raised to the integral of py dy is equal to now to the integral of q of y, which is this, multiplied by e raised to the integral of py dy, evaluated the integral in dy. Okay? So, in solving the linear DEs, it is important to actually memorize this form, or at least familiarize ourselves on how we are going to reduce the D in this form. Because you must memorize this, because definitely, in order for you to solve DE, linear DE, you have to put the D in this form. If you are able to put the D in this form, then that is said to be a linear D, or in this form, in our second equation. And again, our dependent and independent variable is not only limited to x and y. So in applications of DE, you have the current over time here. So it varies. Okay? So let's try to solve. So for example, this example. So we have x d multiplied by dy over dx plus y is equals to x cubed. So our goal here is to make this DE look like in our linear in what? Linear in y. Okay? So why did I say that is a linear in y? Because definitely if you're going to look at the dependent variable of this DE, that is in terms of y. So I can say that that is a linear in y. And here is our formula or our form in linear in y. Okay? So, I would make this DE look like this. So, if I'm going to divide both sides or multiply both sides or divide both sides by 1 over x, so what will happen? This should be dy over dx plus 1 over x multiplied by y is equals to x squared. As you can see here, we have written this D already in the form of this linear in y differential equation. Why? We have dy over dx, that's a check. We have p of x, this is now our p of x, okay, multiplied by y, and this is now our q of x, okay. And again, a while ago, we have a formula that if the differential equation is linear in y, we can solve the d by, okay, y times e raised to the integral of p of x dx is now equal to the integral of q of x e times e raised to p of x dx and dx here. So, if we're going now to solve the solution for this DE, okay, we simply copy y because that's the formula. We simply copy the e. Integral of p of x dx, our p of x here is 1 over x dx, and that is equal now to the integral of q of x, which is the x squared multiplied by e raised to the integral of p of x, again 1 over x dx here. And then, okay, then lastly, we have dx here. So if we're going to evaluate this, y e raised to, this is simply integral of dx over x is equal now to the integral of x squared e raised to, still the same, dx over x dx here. So if we're going to evaluate this is y. Integral of dx over x is ln of x is now equal to integral of x squared e raised to ln of x dx. And as we can see here, e raised to ln will cancel, okay? And we are left with what? We are left with y multiplied by x, because again, if we cancel this, the only term that would be remaining is the inside function of the ln, which is the x. Okay? And equal now to the integral of x squared multiplied by x dx. So, our solution would be x to y, okay, integral of x cubed dx. So, we have xy, x raised to 4 over 4 plus a c. Now, this is the solution to our linear differential equation. The solution or the final answer may vary, but as long as you are done integrating, as long as you are done with the integration, this could be considered as the solution. But oftentimes, if you are having a multiple choice question or whatsoever, okay, your professor requires you, sometimes it is expressed in terms of y. So, if you have that, x raised to 4 over 4x plus c over x. Okay? So, we have y is equals to x cubed. This should cancel, okay, over 4 plus c of x. So, this can still be our answer. Okay? So, let's try again another problem. So, for our problem number 2, we have dy over dx plus y is equals to e raised to 2x. Okay. So, now this is an easy problem. Why? Because the given d is already in the format or in the form of dy over dx plus p of x multiplied by y is equals to q of x. Okay? So, why did that happen, sir? We have dy over dx here. Okay? Of course, that is a linear in y, I presume. Right? So, plus y. Where is the p of x? The p of x here can be equal to 1. Okay? And it is equal actually to 1 because 1 times 1 times y is still equal to 1. So our q of x here is still e raised to equal to, oops, let me just rewrite. Q of x is equal to e raised to 2x. So, if we're going to solve this, so we should use again the formula we have used a while ago. That is y times e raised to p of x dx is equals to integral of q of x e raised to the integral of p of x dx, then dx here. So we have the value. So we have y e raised to integral of p of x is 1. So this is simply integral of dx now equal to the integral of q of x e raised to 2x multiplied by e raised to the integral of p of x is 1. So this is simply dx and we have dx here. So that is y e raised to x because the integral of dx is x is equal to the integral of e raised to 2x multiplied by e raised to x, right? And we have dx here. And as you can see, by laws of exponent, these two have the same base, so we can rewrite this as y e raised to x is equals now to integral of e raised to 3x dx. So if we evaluate the integral on the right side of our equation, we have 1/3 e raised to 3x plus c. Okay? So, and if we're going to simplify this, this can be the answer. But if you're going to simplify this, okay, furthermore, if we're going to express this in terms of only in terms of y, we have e raised to 3x over 3e raised to x. I divided the whole equation by e raised to x just to eliminate the e raised to x here. So we have plus c over e raised to x. So as you can see, by properties of exponent, e raised to 3x divided by e raised to x, that should be y is equal to e raised to 2x over 3 plus this this e raised to x, I can put this on the numerator such that it would have a negative exponent. So this should be our answer. Okay? So we did nothing special here, but we apply our knowledge in algebra. Okay? So by laws of exponents. Okay? And of course, the integral. So again, another example so that we can practice our skills in solving. So we have x plus 3y dx minus x dy is equals to 0. Now, this type of differential equation, we cannot actually see whether it is dependent in y or linear in y, I'm sorry, or linear in x unless we distribute this. So we have x dx plus 3y dx is minus x dy is equals to 0. So the thing here is clear. Okay? Here is the secret. If the dx or the dy, you're going to look at the dx and the dy, definitely because that is the dy over dx or dx over dy. So that would depend on what is the linearity of this d. Is it linear in x or linear in y? So if the dx has a greater term, okay, we have two terms of dx here, x ds plus dy dx, then that is not linear in x. But if we see, okay, only one term with dy, then that is the linearity of our dE. Okay, that is linear in y. So if we're going to transpose this on the other side, we have x dy minus x dx minus 3y dx is equals to 0. So if I'm going to divide this both by So what will happen here is that we divide this by dx. Okay? So what will happen? We have x dy over dx minus x minus 3y is equals to 0. And if I'm going to further transpose this x on the other side of the equation, we have this equation. Okay? And actually, I still have to eliminate, x here for this dy over dx to be left alone on this side, on this term. So what will happen? We divide it by 1 over x. So we have dy over dx minus 1 over x multiplied by 3y is equals to 1. Or, of course, we have dy over dx minus, okay, 3 over x, okay, multiplied by 1 is equals to 1. Why? Why did I get the 3 here? Because our formula, our form for linear in y is dy over dx p of x multiplied only by y. So I have to isolate y here is equals to q of x. So now we have our dE written in linear in y, in the form of linear of y. So what will happen here is that, okay, we apply the formula again. Y e raised to integral of p of x dx is equals to an integral of q of x e raised to the integral of p of x dx and dx here. Wherein our p of x here is this. Okay? Our negative 3 over x here. Okay? So we simply substitute. By the way, this is our q of x, the 1 here. 1 here. So q of x can be 1. Okay? Can be a constant. Because we have written already the d in this form. So we have y multiplied by e raised to the integral of negative 3 over x. That is our p of x, including the negative dx, is equal now to the integral of q of x, which is 1, multiplied by e raised to negative 3 of x dx. We have dx here. Okay? So to evaluate, we have y e. Okay, evaluate this integral. We can factor out negative 3 outside of the integral. We are left with dx over x here. And the same way goes here. We have negative 3. We have dx over dx here, and we have dx here. So what will happen if we evaluate that? We have y multiplied by e raised to negative 3 ln of x is now equal to the integral of e raised to negative 3 ln of x and dx here. Okay? By properties of natural logarithm, we can rewrite this as y e raised to whatever constant inside of the ln. We can make this the exponent of the inside function of the ln. So we have ln of x raised to negative 3. And that goes the same for this integral. We have e raised to ln x raised to negative 3. We have dx. So, we can cancel out, of course, e raised to ln here. And then we're going to get y multiplied by x raised to negative 3. And this is now the integral of x raised to negative 3 dx. Evaluating the integral, we have yx raised to negative 3. We have x, negative 3 plus 1, that is negative 2 over negative 2 here, plus c. Okay? And if we're going, again, to at least somehow get the simplification of this, okay, the simplification of this, we can still, what? We have y is equals to x raised to negative 2 over negative 2 x raised to negative 3 plus c over x raised to negative 3. And if I'm going to apply the rules of exponent, we have, well, let's say I'm going to factor out negative 1 half first. So that is multiplied by 1 over, I can bring this down, x squared multiplied by x, okay, x negative 3 here. Okay, so plus c over x raised to negative 3 here. So what will happen is that we have y is equals to negative 1 half, and by loss of exponent, we can add the exponent. So 2 plus negative 3, that should be 1 over x raised to negative 1. Negative 3 plus 2 is negative 1, plus c over x raised to negative 3. And furthermore, we have y is equals to negative 1 half of x, okay, plus cx cubed. This is also an acceptable answer, okay? And of course, some problems, even books, okay, leave the other side of the equation as c. So another possible answer is that we have 2y is equals to negative x. If I'm going to multiply both sides of the equation by 2, notice that this c would still not be affected because it has a constant here. So we have negative x plus cx cubed here. Okay, in terms of cx cubed, we have, okay, cx cubed here is equals now to 2y plus x. This is another acceptable answer. Okay? So that is the answer for our DE. Okay, let's try to solve again problems. So for what problem is it right now? For problem number 4. 4, we have the given, which is y dx plus 3x minus xy plus 2 dy is equals to 0. If I'm going to distribute this y dx plus 3x dy minus xy dy plus 2 dy. As you can see here, okay, you have already an idea that this is a linear in x. Why? Because we have only one term in terms of x. Okay, so if I'm going to actually rearrange this furthermore, we have y dx, okay, plus, can I factor out x in here? So we can factor out x in here. So we have, okay, x multiplied by, I can factor out also dy, x multiplied by 3 minus y dy, okay, plus 2 dy is equals to 0. Okay, so furthermore, y dx plus x times 3 minus y dy is equal to negative 2 dy. Agree? And if this is linear in x, remember that our formula for linear x is dx over dy plus, we have p of y multiplied by x, okay, is equals to the q of y. So if I'm going to multiply both sides of the equation such that I'm going to eliminate y here and I'm going to add or to have dy here, so what will happen is 1 over, I'm going to eliminate y here, we have a y here, okay, and multiplied it by dy, so as to cancel dy's here. So what will happen is that we have dx over dy plus, okay, plus dy's will cancel here. So we have x multiplied by 3 minus y over y, okay, is equals to, again, dy's will cancel, negative 2 over y. As you can see here, class, that we have transformed this d into a linear form. Whereas, okay, if we're going to separate x here, this is separated already, x, that is our x. This is our p of y, as you can see, purely in terms of y. And this is our q of y. So hence, that is linear. Again, linear in what? In the dependent variable x. Linear, in x. Okay? So let me just rewrite this so that we have enough space. Dx over dy plus x multiplied by 3 minus y over y is equals to negative 2 over y. So this is the same as this. I only factor out x because that is our x term. So this should be our 3 minus y over y should be our p of y, and this should be our q of y. Okay. And furthermore, if I'm going to rearrange this, Okay, so that it's easier for us to integrate this because we're going to integrate this. Okay, remember, if remember we're going to integrate this because e raised to integral of py dy. So plus x, if I'm going to simplify this, that is 3 over y minus y over y is equal to negative 2 over y. So if I'm going to simplify, dx over dy plus x multiplied by 3 over y minus 1, okay, is equal to negative 2 over y. So I've distributed the negative here, okay, such that this can be rewritten as this, okay. So you can see y's will cancel, will give you 1, okay. So this is our p of y, and this is our q of y. And again, if we're going to recall what is the formula, if that is a linear x, that is x multiplied by e integral of p of y dy is equals to integral of q of y multiplied by e raised to p integral of p of y dy and dy here. Our x is simply x, okay, that is our dependent variable, multiplied by e integral of p of y, that is 3 over y minus 1 dy is equal now to the integral of q of y, that is negative 2 over y multiplied by e raised to the integral of p of y, which is 3 over y minus y 1 dy, and we have dy here. Okay. Notice if we're going to first, okay, evaluate this. Let's evaluate the integral. Okay, I'm going to first evaluate the integral for you. 3 over y minus 1 dy. We can separate the integral sign and the dy. So we have integral of 3y dy minus 1. Okay, that is equivalent to dy. So I can factor out 3 outside the integral sign. We have dy over y here minus the integral of dy. So if you can see, we can integrate this. So we have dy over y is 3 ln of y minus y. Okay, and if we're going to this is only the exponent of the e here. So we evaluated. So if I'm going to rewrite, that is x e raised to 3 ln of y minus y. That is the evaluated integral we have evaluated a while ago. That is only the exponent of e is now equal to the integral of negative 2 over y multiplied by e raised to 3 ln of y minus y dy. Okay? So, we should simplify this first. We know that by properties of exponent, we can derive e raised to 3 ln y minus 1 as e raised to 3 ln y minus e, okay, minus e, okay, raised to y. Okay, we can rewrite this at that form. Okay, oops, I'm sorry. This is not this, but rather this is multiplied by e raised to negative y because we have this form. So this is the loss of exponent. E raised to 3 ln y minus y can be rewritten as this. Okay? So because if we have two bases here, we can definitely add. Since this is negative, it results to minus. So, okay, this is a multiplication. We can add exponents. But we did the reverse thing. Okay? So this can be rewritten by loss of exponent as this. And that is equivalent to now negative 2 over y. The same thing I will do here. E multiplied by e raised to 3 ln of y multiplied by e raised to negative y dy here. So as you can see, applying the properties of natural logarithm, we have e x times e raised to ln of y cubed multiplied by e raised to negative y is now equal to negative 2 over y, the same, e raised to ln of y cubed multiplied by e raised to negative y dy. And as you can see here, okay, as you can see here, this e raised to ln will cancel and we are left with x y cubed e raised to negative y here, and we are left with the integral of negative 2 y here as over y cubed multiplied by e raised to negative y dy. So I can factor out On the right side of our equation, the negative 2, integral of y cubed over y, that is a multiplication multiplied by e raised to negative y dy in here. So, we can see that this will cancel. This should be y squared. So, we have xy cubed multiplied by e raised to negative y. We have negative 2 integral of y squared multiplied by e raised to negative y dy, and this is an integration by parts. So as you can see, we can let u as y squared, du with respect to y is 2y dy, integration by parts, and we let dv as what? E raised to negative y dy, and we let b, we evaluate the integral of this, that should be what? Negative e raised to negative y. Yeah, that is the thing. And the formula for integration by parts is again ub minus the integral of b du. Okay? So, we should learn, or we should have learned this in our integral calculus course. So, negative 2 multiplied by ub minus b du. Our u is y squared multiplied by b, negative e raised to negative y, minus the integral of b, negative e raised to negative y, du. Our du is 2y dy. Okay? So, upon simplifying, we have, okay, first, negative 2, negative e raised to negative y squared. Okay? We can factor out 2 because it's a constant, and the negative sign here. So, negative 2, we can factor out negative 2. And this is a minus, so that becomes 2 integral of e raised to negative y multiplied by y dy. And again, no, we have to distribute negative 2 here. Okay? So, we have positive 2y squared e raised to negative y, okay, plus, or sorry, negative 2 times 2 would be minus 4. The integral of e raised to negative y, okay, multiplied by y dy. And as you can see, we're going to get the integral again of this. That is again integration by parts. So we have to let u equal now to y. Derivative of u with respect to y is dy. Our dv now would be e raised to negative y dy. Still the same. Our v, we get the integral of this, negative e raised to negative y. So, upon continuation of our solution here, we have xy cubed e raised to negative y is equals to 2y squared e raised to negative y minus 4 multiplied by the integral of this, that is ub minus bd. We have negative y e raised to negative y, okay, that is u times v, minus the integral of b du, negative e raised to negative y. Then we have, finally, we have dy here because du is equivalent to dy. So upon simplifying, we have xy cubed e raised to negative y is equal to 2y squared e raised to negative y. Okay? If I'm going to simplify first this, I can what? I can factor out negative sign outside the integral sign. So minus negative, that becomes positive. The integral of e raised to negative y dy. And if we're going to distribute the negative 4 term here, or the constant negative 4 here, so that becomes plus 4y e raised to negative y. And this is minus 4. The integral of e raised to negative y is negative e raised to negative y. Don't forget the plus c. So, if we rewrite this, we have 2y squared e raised to negative y plus 4y e raised to negative y. Negative 4 multiplied by this negative, that should become plus 4 e raised to negative y plus c. Okay? And as you can see here, okay, we can multiply this full equation or simplification by 1 over e raised to negative y. So that what will happen, our e raised to negative y here will cancel. Okay? And but in our term of C, okay, we will be having this 2y squared plus 4y plus 4 plus c over e raised to negative y. And furthermore, if I'm going to bring this up, we will be having a positive exponent here of e y, 4y plus 4 plus c multiplied by e raised to y. This can be the final answer for our linear DE. So, down to our last example for this video of linear DE, first order linear differential equation. We have y minus cosine squared x, okay, dx plus cosine of x dy is equals to 0. Okay, first we distribute this. We have y dx minus cosine squared x dx plus cosine of x dy. Now, I can rewrite this as cosine of x dy plus y dx minus cosine of squared x dx is equals to 0. Now, if this is a linear DE, okay, what will happen? If I'm going to multiply the whole equation by 1 over dx, okay, such that I'm going to eliminate dx here, we have cosine of x dy over dx plus y minus cosine squared of x is equal now to 0. Okay, as you can see here, we have dy over dx here. So it means this is linear in y. And furthermore, that is our guess. But this is linear in y because, again, the dx here, we have two terms of dx here. Then definitely, that is not linear in x. Whereas we only have one term of dy here. So we can assume that that is linear in y. So furthermore, if I'm going to do this, we have plus y. I'm going to transpose this cosine squared x on the other side of the equation. We have cosine squared x here. And what do we need to do? Linear in y is dy over dx plus, again, p of x times y is equals to q of x. Okay? And I'm going to divide this by 1 over cosine of x. So, dividing that, dy over dx plus y over cosine of x is equal to cosine squared x divided by cosine x is cosine of x. So, furthermore, if we rewrite this dy over dx plus 1 over cosine of x multiplied by y is equals to cosine of x. As you can see, this is the linear in, again, linear in y. And we have the 1 over cosine of x as p of x. And we have cosine of x as q of x. So, by our formula again, we have y e raised to integral of p of x dx is equal to the integral of q of x multiplied by e raised to integral of p of x dx, and we have dx here. So, substituting the values, we have y e raised to the integral of p of x, where is our p of x is cosine of x, 1 over cosine of x dx is equal now to the integral of cosine of x multiplied by e raised to the integral of 1 over cosine of x dx, and we have dx here. And 1 over cosine of x, okay, is equal to secant. Okay, so y e raised to the integral of secant or secant of x dx is equal to the integral of cosine of x e raised to the integral of secant of x dx. We have dx here. Okay, can we evaluate the integral of secant or secant? So y e raised to the integral of secant x dx is ln secant of x plus tangent of x is equal to integral of cosine of x, okay, e raised to the ln of secant of x plus tangent of x. We have dx here. As you can see here, okay, I think we have to move this right here, okay. So we have e raised to ln will cancel here. So what will happen to the equation? We have y secant of x plus tangent of x here is equal now to the integral of cosine of x multiplied by secant of x plus tangent of x dx here. Okay, let me just write this side of the equation as this. Okay, if I'm going to multiply this, this should be cosine of x multiplied by secant of x plus the integral of cosine of x multiplied by tangent of x dx. I'm sorry, we have dx here. I forgot to write. So I should rewrite this first as this. Okay, this. So integral of cosine of x. Secant of x is 1 over cosine of x dx. So definitely this would cancel. Plus cosine of x. Tangent is equal to sine of x over cosine of x dx. So what will happen? This would cancel. And we are left with, again, y, okay, is equal to simply the integral of dx. Okay? Plus the integral of sine x dx. Okay, we know how to integrate this. Y secant of x plus tangent of x is equal now. Integral of dx is x. Integral of sine of x is negative cosine of x plus c. And this should be our final answer for this problem. And I hope you guys, you learned something today. Okay, thank you so much for listening again. Don't forget to subscribe to my channel and share these videos or channel of mine to every engineering students who are struggling currently in their differential equation subjects. So thank you so much for listening. I hope you learned something. God bless you. See you again on the next video.